So good afternoon everybody, and you're very welcome. I know some of you have been here to Unit 18, and for some of you it's your first time, and welcome. My name is Mary Coakley and I'm the Community Engagement Manager for this part of Trinity that we now call Trinity East. We just like changing the name every few years, so I know a lot of people would say the old IDA Centre of Trinity Technology and Enterprise Campus, now it's Trinity East, and there are plans to redevelop, not on a big grand scale, in a much more sustainable way. You know, there's buildings there from the 70s, 80s, and the new provost, Linda Doyle, wants to repurpose and reuse, rather than knocking down everything and rebuilding. We have space, so let's use it. But the great thing about this site, I think, that in 2021, one of the first places to open on this site again was this Unit 18, which is designed for the community, because we realised we could do more in Trinity to reach out to our neighbours. It's about building relationships, getting to know the people who live around here particularly better. You know, just to say, oh hello, and we are Trinity, and we do lots of things. It's not just formal education. So since then, lots of different groups have been using this space. And they do their own thing sometimes, and sometimes we do things with them, so it's that mixture and that balance. So we have groups like St Andrew's Resource Centre, the youth group working with CBS West Monroe have been in here. We have Vincent de Paul on a Monday. We have Extinction Rebellion Art Group on a Wednesday evenings. And we have the National Performing Arts School in Saturdays all day. So there's a nice mixture of ages, not just for young people, or it's for, as we can see here, it's great to have such a diversity of ages and nationalities and backgrounds, and that's what it's all about. It's for everybody. And if there's something that you want to do in the community, because it's hard to get space, and people say, so come to me and ask me. Now this came about, this series, and this is the first of a 6-week series. Betty Ash, local resident, came to me and said, over 10 years ago Trinity did this great series in St Andrew's Church in West Monroe, and why can't we have that again? So I said, okay, well you can have it again. Who do you want to speak? And let's do it. And mostly from her work and her networking in the community, because I know a lot of you heard about it through her. This is how it's come about. So thank you to Betty and to all her networks. And hopefully you'll come to the next few weeks as well. The programmes are on the table over there. Thanks also to Dylan Clayton, who's leading his team with Finn and Mel on the video. And the great thing is they're local. They're from Ringsend Rock School, in fact. And the two guys have a band that are called Pants on Fire, so look out for them. They're an upcoming band. And of course, last but not least, thank you to our speaker today, Professor Cliona O'Farrelly. Now, many of you will have come across her in the media over the last particularly couple of years. She's Professor in Trinity School of Biochemistry and Immunology and has devoted her professional life studying immunology. So she featured a lot in those darker COVID times, but of course always presents it in a positive way, and she's a great advocate for clear, effective science communication, and we really appreciate her taking the time to come here. Needless to say, she has her team of, she's lecturing, she's a team of researchers, she's doing a lot of research, but she's come along. So thank you very much, Cliona, and over to you. Over to Cliona.
Okay, go ahead. Thank you so much, Mary, and thank you, Betty. And can you believe it? I was one of the people in St. Anne in the church, but we had great fun talking about fertility, cows, Hollis Street, and James Joyce. Yeah. So today is going to be a completely different topic, and I'm going to bring you right back to the topic everyone wants to forget, and that is COVID. It is so hard to believe that we've actually lived through a pandemic. And one of the main ironies that us immunologists had when the pandemic unfolded was how surprised everyone seemed to be that it was happening. Because us immunologists, and I did my primary degree in microbiology, so I'm also kind of a microbiologist, but on the infectious disease, what we've been telling people all the time is that there will be a pandemic. There will be a pandemic. There will be a pandemic. Okay, we can't tell you when, but it is going to happen. And when we teach about it, we look back to the past and we say there have been many pandemics. The human species has evolved because of its ability to be able to eat and reproduce, all right, but also to be able to resist infection. So that is what has made us what we are, and unfortunately is what also makes us susceptible to other diseases, like autoimmune diseases. We developed these genes that helped us handle these infections, but some of those genes now make us more susceptible to autoimmune disease. So that's a topic that I just started talking about before we started here, and I can come back to in the end. But not at the end, as we go along. But let's think. So, as I say, we weren't a bit surprised, and unfortunately, I am going to tell you there will be more pandemics. And so, hopefully, whether it'll be in our lifetime or not, who knows? But for as long as us humans live on this planet in such large numbers, traveling as much as we do, and living in such close proximity with animals, and for as long as there is a multiplicity of microbes and viruses around, which we will absolutely not be able to clear the planet of, then we will continue to become infected. And we need to devise ways of either preventing the infection or being able to deal with the infection, with infections. So that's really what I wanted to kind of talk about here, was what can we do, or at least I think Betty suggested it, Betty, the fount of all really great ideas. She says they don't want to hear about COVID, they want to hear about how you don't get COVID. Is that true? Is that what the rest of you feel like you want to be here for? The only problem is, I'm not going to tell you anything new. I'm going to tell you about some rationale for the things that we know help our immune systems. Or certainly, we did learn an awful lot during COVID in more detail about how things that we knew affected our immune system, we learned more about exactly how they affect our immune systems, and to the benefit and to the detriment. So an awful lot of that information became more available, and people really began to understand it. Again, these were topics that us immunologists were aware of, but were finding it difficult to get out into the public. And so now people are much, much more receptive. So number one on the topic, I shouldn't actually give them, I will start talking about number one. Number one reason why our immune systems become compromised by what we do is our diet, and in particular, not necessarily what we eat, not so much. Lots of people think that if they change what they eat, then they change what we do. It's how much we eat. I don't know whether you know that on this planet now, more people suffer from the detrimental effects of overnutrition than die of malnutrition. So in our lifetime, like when I was a child, I'm a senior citizen, I discovered today. I was wondering, is that what we call people of our age? So I'm old enough to remember when that was the primary problem on the planet, was that we would not have enough to feed people. We absolutely have enough to feed people, and we have the potential to feed everyone, and we are already feeding people, and feeding people too much. And so, again, in a society of excess like ours here in the West, an awful lot of what we eat and how much we eat is to do with the way we have evolved. So it was an evolutionary benefit to accumulate an excess amount so that we had it when the snows fell, or when there was no food. Nowadays, the other reason why it was hugely valuable to carry extra weight was because of temperature. One of the main requirements of energy is to maintain our body temperature. But now we live in comfortable environments where our bodies don't have to do it anymore. the fossil fuels are doing it. Or so that causes another problem, I do realise. And this is why everyone suggests turning down. It's not just to save the fossil fuels, it's also can be of benefit to us. So because we've evolved to eat more than we need and to store it, it is unbelievably difficult to do anything about it. And I know this personally. Nobody will believe it looking at me that I have a problem with my weight, but I absolutely, and I certainly didn't have when I was tall and skinny and young. I'm shrinking, older, had 3 kids, and so I'm huge, and I'm a pig. And absolutely, I love my food and I love my wine. So, and during lockdown, lived with my husband and my son. We also live in Irish town, so we come back at least twice. But during the lockdown, we were living in Wexford. And we all love to cook. We all love to bake. And this skinny young son is a particularly good baker. So we were having 3 full meals a day and treats. On went the COVID stone. And I said, and I could feel it going on and going on and going on. Trying to get rid of that stone is the hardest thing I have ever done in my life. And I've done hard things. I've run a marathon. I have trained and run a marathon. I have given birth 3 times without anaesthetic. I've done a PhD. I've survived a career in TBS. Seriously, I don't mean to belittle it. This is why I'm trying to express such sympathy for how difficult it is to shift weight. So therefore we can't just wake up in the morning. I can talk afterwards privately about what I've done. I luckily don't suffer from bulimia or those other things, but I do have quite, it's a fasting technique that I'll tell you about if you want. But there is absolutely no point in, after this, going home and saying, I'm going to lose the stone, or I'm going to lose the 5 stone, or I'm going to lose whatever. That is just impossible, and you can't maintain. You might spend 2 days on this special diet, or you might spend a week. But inevitably, again, as everyone knows, if you do it that way, it'll all go back on again. So, we link to the second most important thing, and that's where they should be equally, if only I could speak twice and be telling you about the weight, and the other thing you'll be a bit surprised I'm going to mention, exercise. The 2 are inextricably linked. And again, I have huge sympathy for people who have mobility problems, who have caring problems, who have all sorts of others, live in not safe places, who can't get out and walk for whom. So it is a huge difficulty. And again, we have evolved not to take exercise. We have evolved to conserve our energy. So we all choose. I work, the lab is down in TBSI, a huge building down there beside Western Grove, near down there. Chock-a-block, all the students are back now. And luckily, the lifts now are so bad, I see them on the stairs. But I get so mad at all of those young people getting the lifts. Whatever, it's bad enough them getting the lifts up the stairs. But coming down the stairs, I see them standing there waiting for the lift to go down. It is fascinating. And these are all supposedly smart young people, who want to live to be 100 and could live to be 100 if they keep the weight down and the exercise up. But our natural tendency is to take the easy route, is to conserve our energy. That's what we have evolved to do. So, it's just as difficult to get out every day and do the exercise. Again, there's no point in saying, you're going to run a marathon. I did a marathon, way back when I was 19, and when people are full of madness, and they do things like say they're going to do a marathon. For most of us, we cannot do something massive like that continuously over a period of continuously over time. So we have to think of ways of doing it little by little, setting small goals. To come back to how both the diet and the exercise affect the immune system. With excess calories, we know we're laying fat everywhere, but we lay fat in the liver in particular, and then the fatty tissues, more of it underneath the skin. And what that excess is really interesting about us needing energy to run an immune response. When there's excess, the immune response is not as effective. And in particular, some of the very first studies that were done in this area was done by an Irish group, who somebody has become quite famous in immunology, Lydia Lynch, with Donal O'Shea. Many of you will know him as the endocrinologist out in St. Vincent's, who is passionate about trying to do something about overweight in our country. We have, all the developed world has a massive overweight problem. But he and Lydia, I happened to be involved, I happened to be working out at Vincent's at the time, were amongst the first to demonstrate that natural killer cells, which are cells of the immune system, really important in viral infection, do not work as well in people with very high weight. And what Donal and Lydia went on to show was when the weight is reduced, now this is in bariatric surgery, so these are very extreme examples, the immune system came back to normal. So really emphasizing that we can do something to help restore our immune system. The second area of research, this other one about the exercise, again, it's been shown, a lot of this work, as I said, was gathered during the time of COVID, that regular exercise, and this is not anything extreme, nothing to do with gyms or weightlifting or marathon running, but regular walking. The 10,000 steps was an arbitrary one that was chosen, and it's not necessarily 10,000 steps, but it's the regular doing something. It changes the activity of the immune response, so as to improve it so that the cells work better and you get a more effective response. Now, one of my students, see some of the guys in the lab are down the back, and before I finish on diet, there are so many things that we could talk about, but one of the first things that everybody always asks about is about vitamin D. And there's innumerable studies out there looking at vitamin D and claiming that vitamin D, so taking supplements, and I know some of you will be asking about those, and there is very little evidence that any of the supplements make a significant difference. But vitamin D, so many papers claiming it, but the studies are always flawed. But Cian, that he's going to blush now, except he doesn't blush, down the back, when he did his PhD with a colleague of ours, Kieran Mead, he did a vitamin D study that did affect the immune system really clearly. It was in calves. Because we can control the diet and the age and how they're looked after of calves, we can't do equivalent studies. But I thought it was a really, really important paper, but Kieran Mead is unbelievably humble. I was saying to them when the paper came out, we have to make a big deal about this because this is really showing something and it proves that it does do something to the immune system. But they're too humble. So he said to me this morning, you have to mention it. Do you want to comment here? Not really. He seemed to talk about the COVID.
Could I ask you about vitamin D and bones, old bones in particular?
Yes.
Is one supposed to take more vitamin D to help old bones?
Yeah, I don't want to say. I'm a research scientist, and I'm not a clinician. I don't want to say either do or don't do anything. And if you're being recommended by somebody, then but vitamin D, there is not overwhelming evidence. Is that okay? But back again to the healthy diet, you see, and having the balanced diet and fruit, vegetables and dairy. This comes back again where you will see problems with bones. Often we'll discover that the person is on some sort of a limited diet for some sort of other reasons. So this is why this question is so complicated to study in humans of the Western world, because so many people have oddity diets. When you compare, where they are not eating something, or they're eating an awful lot of something else. So that's why the balance is just so important. Because that's enough for me to say. I think on that. Yeah.
What about in populations that either get no sunlight or they have I mean, you mentioned the poor diet, or they have dark skin and they live in Ireland. Do you see clear effects there that you could map onto?
Not clear. I mean, this was one of the reasons why in Ireland vitamin D became such a huge thing, was because there seemed to be a higher incidence of multiple sclerosis up in Donegal and a lower incidence in Wexford. And the hypothesis came that it was to do with less sunlight up in Donegal and much more in the sunny southeast. And Niall Tubridy, not the Ryan one, the Niall one, a neurologist out in Vincent's, and Jean Fletcher here in Trinity did a huge big trial giving vitamin D to multiple sclerosis patients on both sides, and saw no change in the progress of the disease. But that did not prove, it doesn't go anywhere near, and that's only an example of a study, Patrick. It really absolutely doesn't negate what you're suggesting, because what you really want to ask, you want to keep them on that diet for a long time. Look at the incidence of multiple, because it's really it won't put back the immune system the way it was, but might it actually prevent it? And so, or might it actually prevent? This is why it is just so hard to study. But can I mention, so we've mentioned diet, we've mentioned the other one again, most people. Two more things that are linked that you'd like to be talking about at the same time that really impact on our immune systems, beneficially or different. The first, or not first, one of them is sleep. So good quality sleep has been demonstrated that people, or put it the other way around, people who don't sleep well often have a more inflammatory profile. So in other words, their immune system is kind of triggered a bit. And where this is particularly interesting, I need to look up this poem for you, is in the brain. I don't know where, actually, I was going to ask that. I'm not sure where all you guys think your immune systems are. You all kind of have an idea of where your liver is. Everyone knows kind of where their stomach is, where their heart is. Where is your immune system? Yeah?
The thymus.
Cells, white blood cells.
White blood cells? Here's somebody who knows. She's cheating. White blood cells, spleen. Yeah?
Yeah, blood, yeah.
Blood. Your immune system's actually everywhere. I was saying, so where we're really vulnerable to infection is where we're exposed to the outside world. We have this tube in here that is inside. It's actually connected to the outside. And it's not even a hollow tube. It's covered in finger-like projections. So if you were to spread it all out, there's a surface area exposed to the outside, up and down, that will cover twice this room. So that's where the bugs get in. And then that's the lungs. If you were to flatten them out, they would cover the size of this room. So you have this surface, and every time you breathe in, you have this surface area that's exposed to outside. So this is where the bugs come in, the best place for them to come in. And so this is where you really need an immune system. So you actually have a massive immune system in your lungs, in your gut, in your liver, in the uterus, in the skin, and in the spleen. And I saw somebody pointing to their tonsils, your lymph nodes that are all around. They're collections of specific, but you do have an immune system everywhere else. And in the brain. So all these cells that are in all of those places are what we call phagocytic cells. They're gobbledy cells. They're able, what they do is take up stuff and digest, clear off stuff. If it's a bug that gets in, what they seem to do what it's thought that they do in the brain, in microglial cells you may have heard of, what they do is clear up the debris in the brain. And it seems that they are most active in sleep. And so if you don't sleep much, these poor cells, they don't get to do their job. And so you're left with crud in the brain. And so it's a really good example of where sleep really helps our immune system. So the corollary of that is, and again kind of related to it, is stress. Again, this is why what I'm saying is not useful at all, because you actually all know this. You know that stress compromises the immune system. When we're stressing, but the data, to tell you some of the data, again, our natural killer cells are not as functional. Again, I was only talking about this study. I don't know why I keep talking about Vincent's. I've been 17 years in Trinity, and the whole point of this is about to tell you about research that's going on there. I don't keep telling you about it, pointing out there to Vincent's, but actually Vincent's is there, isn't it? Anyway, I collaborated, used to run the research labs out there and collaborated with brilliant professor of psychiatry, Malone, and one of his interests was inflammation and anxiety and stress. And a brilliant girl, Eva O'Donoghue, did a joint PhD with us looking at exactly this. And looking at people, one study looked at people with high levels of anxiety, and another study looked at people with high levels of depression. And it was so ahead of its time. This was all 15, 16 years ago, at the very beginning of when people were realizing that stress compromised the immune system. And what did we see? We saw high levels of these proteins called cytokines, inflammatory cytokines, in the people and they were higher in the people who were stressed, suggesting that they were more susceptible, or their immune systems were compromised. And again, when methods of helping with the anxiety were introduced, then they came back to normal. And so people who are highly stressed, and again, it's very relevant to the further discussions that we're going to be having here, is about quality of life and people living in stressful situations. And poverty is becoming well known, and there are quite a few people in Trinity interested in this. Some of you may know Cliona O'Farrelly, an infectious diseases doctor up in St. James's, again, who played a very active role during COVID. But one of her real areas of interest is how socioeconomic status, poverty, and the struggle of poverty contributes to ill health. And one of the reasons that we're just discovering this at the moment, that people who live under stressful conditions due to poverty, again, their immune system is compromised in a particular way. So the constant stress of everybody is aware of what it's like not to know where you're living, or what you're going to eat, or whether it's going to be enough, or what's going to happen to your children. That inevitably is associated with higher levels of infection and other forms of where the inflammatory response is compromised. And if that stress can be alleviated, which is the bit that I'm going to, I'll do this a little bit first, and then see how you'd like to comment on that. So, what do you do about stress? Again, so like this, you can't tell somebody to sleep well any more than you can tell somebody to take exercise every day, any more than you can tell anybody you only need half of what's on the plate. This is so hard. The stress is exactly the same. And I was there talking about the stress of poverty, but I've been meeting our new MSc students all this week. Every single one of them is talking about stress and needing therapy. You know, they're so damaged by COVID. So this comes back again to, it's not just the infection itself that's caused damage. Again, you all know this. It's what the lockdown did, what the weird living did, the stress that put in. So all of these young people, and so I'd love to do a study on infection in them. What do we do about it? I tell them all, of course, because I'm a nanny and I'm ancient. I tell them all, you get out there and do exercise, get out into the fresh air, just cut down on your screen time. Again, and then these other two things, the exercise, but they have to find a way themselves. We all have to find our ways ourselves. But a hugely valuable one that several of them commented on that they discovered themselves was yoga. Yoga, which I discovered as part of my getting rid of I needed to do all this exercise and then I was stiff, and so then I started on yoga, and then I discovered this brilliant woman in Texas called Adrian, who is awake and offering class 24 hours a day. So when I can't sleep during the night, I come downstairs and I turn on Adrian. And the yoga, it's just fantastic. She's all sorts of things. But my favourite is, what does she call it? Extended, where's the little Sienna? Extended child's pose. Do you know this one? Very good. Now, what does it remind you of? When you spread out your knees and put your hands up. And it feels so beautiful. I tell you, it feels. Now, it doesn't for everyone. But what does it remind you of? Baby sleeping. The baby sleeping, yes, the child. Yeah, the child's pose. But the prayer for Mecca. So, coming back with the stress and then the yoga and about, if you think about organised religion and the various practices, so, and what they do, if you think about the practices in several of the religions and how they benefit, and in particular what's so interesting is that they are translating into direct effects on the immune system. So I can't say child's pose has made my immune system better. I'm not trying to say that at all. But the yoga, the mindfulness, is one of the mindfulness, and if you think so, the Dalai Lama, so this is a totally different religion, and the Dalai Lama has a major interest in neuroinflammation, in how the practices of Buddhist religions and meditation and mind actually impact on brain activity and the immune response. So that's all this work is beginning to translate into us understanding the immune system being so much more than just responding to viral infection. The other religious practice that will be directly will trigger in you all of my generation, not those young people down the back, would be saying the rosary. Going through saying the rosary just is talk about mindfulness or mindlessness, and talk about emptying the mind. When you read any of the Dalai Lama's recommendations, it's all about trying to, what we're supposed to do to get rid of the stress is empty the mind. And if you remember, I went to convent schools, cheap was the number of rosaries that I have said, but it does empty the mind. The fourth one that I'm going to mention, which again has been out, the mindfulness, as I say, there are studies showing that affects the brain activity. The effect on the immune system is less direct, but where there is evidence on the immune system is fasting. So again, nearly all religions have some form of fasting. In the Catholic Church, it used to be Lent, 6 weeks, and then no meat on a Friday, then it was determined Friday. But there was a time when we ate, watched what we ate for 6 weeks. In Muslims, they have Ramadan. Hindus have, Buddhists have very particular, and it's the fasting. The fasting has been of different types. Has been shown to influence the metabolism of the cells and impact on the ability of the immune system to, in a beneficial way. Obviously, fasting so that you starve compromises the immune system. We're not talking about starving here. We're talking about adjusting what comes into what is feeding the immune system. So that's all kind of general. Let's now and see if people would like, and then we'll go on to the last
Can
one.
I just ask you, is the older you get, you need less sleep?
Actually, the next speaker is going to be Roseanne Kenny. The question was, as you get older, do you need less sleep? I don't want to say even yes or no, but that you need. I think the evidence is yes. We need less. We do sleep less, certainly, and we certainly wake up more. And I think I'm really interested in this, because we were talking about this. The cycle of sleep is 4 hours. People think it should be 8 hours solid, and if you don't get your 8 hours solid, so that's the only thing. Don't introduce more anxiety into your lives by trying to do all the things you should do. But so I think as we get older, we certainly see pattern changes a lot. And this is why it can be a huge benefit if we don't have to work as much, so then we can sleep when our body is telling us to sleep. I'll bet you loads of granules, certainly know my body tells me at 2:30, it's time to lie on the couch, which I can do at home. I haven't found a couch in TBSI yet. They haven't caught me yet. Exactly. Whether we actually need more, because again, that we can't do anything about the fact that older age does change the immune system, but all of those things, and that's what Roseanne is going to talk about, Roseanne Kenny next week, do come along. She is a font of knowledge about aging and how to age healthily and better and how to do all of this. She gives practical exercise and she'd give a much more precise answer to you, I'd say. Yeah.
Yeah, my question is here. So my question is about Crohn's disease. I have a person that's very close to me, and she has Crohn's disease. So the consultant came and gave her some pills, and didn't go well. So then we decided to stop it completely, right? And then do exactly what you said. It's fasting, it's gluten. Every food is gluten free, better sleep, and so on. When she come back to the consultant, and the consultant saw the marks going into 0, I mean, perfectly good, he thought that it was the pills. So then, and she told him, no, I actually stopped the pills. What you tell me about, but you don't, it's definitely what you told him, is that you don't have an idea of how to solve this problem, without giving him a pill. So there is a way here that the immune system can be boosted by doing all of that. So what do you think about the medical advice for people with immune diseases? Because
yes, you see, these are the anecdotal stories that make us researchers think really this is very worthwhile pursuing. How do you use either diet or fasting to control the immune system? But just so as to clarify, maybe I should have said this right at the very beginning. All the things that I'm talking about have been shown to have an effect on the immune system, to benefit the immune system in some people, when you do big studies. But they will not necessarily be in this room. There are people with all sorts of conditions that no amount of exercise, our diet, our vitamin D is going to change. And so the thing we really can, at this moment, can absolutely not do anything about is our genes. So so our genes contribute a huge amount. So what has been discovered for definite is with the inflammatory diseases, inflammation makes lots of these proteins that we talk about that cause the damage. And these other methods can be used to control it, and in some people really well, and by the sounds of things like in your partner, and so the fasting, or in someone else it might have been reducing the stress. Those inflammatory diseases are all affected by stress. But what we do know is there's an awful lot of these inflammatory cytokines, and one of the particular, some of you may have heard of it, is TNF, tumor necrosis factor, a really amazing protein that is so unbelievably important to all of our immune systems, but too much of it in the wrong places causes rheumatoid arthritis or inflammatory bowel disease. They sound like two totally different diseases. They're not. They're caused actually by the same processes, just in different places. And what it was like, this is why immunology made this massive discovery in the 80s in discovering those proteins and discovering that if you could block and TNF, so it was so, I remember the rheumatologists and the gastroenterologists being so excited in discovering. Now, that treatment is fundamentally limited because you cannot take it for all of your life, and it doesn't work for everybody, as you've discovered. But what clinician is not going to give it? So when it might work. So this is why we need so much more research. Which brings me to the final bit of today, is to talk about because this event is to celebrate, just as Mary said, is to kind of promote conversation between Trinity and the communities. And one of the most exciting things that we can tell you about is about the research that is going on, trying to fail, and how long it is taking us to find out. But you should know that there are so many people trying their very best, who you don't see behind the clinicians. The clinicians are dealing with patients every day. But there are literally hundreds of people in Ireland, millions and millions of people across the globe, all researching. So to celebrate this research, the EU has a night, EU Researchers' Night, on the last Friday of September. And this is actually where Betty and I first met, was at one of the EU Researchers' Nights. No, actually, we met at the opening of TBSI, but you were a great supporter of the EU Researchers' Nights when we used to open up TBSI and to welcome people in, to give some idea of the research that's going on. And so, particularly, I don't happen to do anything on inflammatory bowel disease, but our research is on the spectrum of COVID. And this is what I was going to mention about inflammation and stress and all the things that cause enhanced stress, or enhanced inflammation, like obesity and like anxiety, compromising the immune system, and that seems to kind of exacerbate long COVID. Many of you will have heard that some people do not fully recover from COVID infection, and they have symptoms going on for months after the infection is cleared. So we're really interested in who are the people, and why is it happening. We're interested in that end of the spectrum, and we're also really interested, just as in the topic I was saying to you, is why some people don't get COVID, even though they've been exposed to it. So resistance to COVID is, and we're part of a big conglomeration, or we're part of, but many of the people, Roseanne will tell you about her collaborations, and the other people who come along in history, there are the equal collaborations, but ours was with a big international group across the globe, and during COVID we used to meet at 1 o'clock Greenwich Mean Time, 1 o'clock Greenwich Mean Time, which was 8 o'clock in the morning in New York, and it was in the Middle East. It was a time that they could come, and the people from Australia used to join. There were 150 of us, and in the first instance what everybody the work was being done before the vaccines happened. And the big question was, why do some people die? And it was found, so 2 huge papers came out. The whole thing is led, you like the name of the leader, is a Frenchman called Jean-Laurent Casanova. You won't forget that. And he really it was a highlight of the week. To wake up on a Monday, knowing there's going to be this meeting, even though we're in lockdown, because you'd be hearing, first of all, he'd give a tiny little introduction. And he was in Rockefeller, even though he's French, he was in Rockefeller in New York at the time. And then you'd see all these people joining at 1 o'clock from across the globe, all working. So half clinicians, half scientists like myself. All the clinicians were seeing the patients, looking after the patients who were really sick and dying. And the deaths, I know we don't want to remember it, but we must remember it because we must learn from it. It's the whole point of today's talk, we must learn from it. And anyway, he's interested in the genes. What are the genes? We've been talking about these other things that affect your immune response, and that is my answer to you about we cannot do anything about our genes. And if we've inherited a bad set, as they say, choose your parents wisely, for all sorts of reasons, we cannot do anything yet. Now, one of our students, the undergrads, asked Cliona that this morning. She said, we were having this conversation, she said, so are we going to be able to genetically edit embryos? I know, we could do, but we're not able to do any of that yet. But if we can understand which are the bad genes that make you much, much sicker, that kill you, then we'll get better drugs. And we'll be able to identify, this is why we need to be doing it before the next pandemic, if we had a way of identifying the people who were going to get really sick and die, we could protect them better. Because I anticipate that the next pandemic, if it happens in our lifetime, there will not be lockdown. I don't think the public will allow not lockdown again. So therefore, we're going to have ways of identifying and protecting the vulnerable people. The other side of the coin, the other side of the coin. So that conglomeration, I've been going on, you only wanted me to talk for 20 minutes.
We're enjoying it.
So I just let them introduce themselves, because I dragged them down here. just as you have a night, because for EU researchers, as I said, for EU researchers night, I wanted to celebrate it. I really wanted you to hear how extensive this research endeavour is on your doorstep, on our doorstep. And we have Sophia, you tell us a little bit, will you?
Hi, can you read?
Just hold on a second, sorry.
So my name is Cian Reid. I'm a postdoctoral researcher in Cliona's lab, and my project is funded by this EU consortium that she was speaking about earlier. And so we're looking at specifically what is it in our genes that makes people resistant to SARS-CoV-2 infection.
He talked for half an hour this morning in extraordinary detail about these genes, but he's saving you. Yeah, please, better, yeah.
Hello, hi, I'm Federica Giangazzi. I'm also a postdoctoral researcher in Cliona's lab, and I kind of have a joint project on COVID. So I'm looking at why certain people don't get COVID despite being exposed to it, so through their partner or by their jobs, and why certain people don't get COVID. So that's one question. And then the other question is why certain people who got COVID cannot clear the infection, so they have these post-COVID, long COVID sequelae. So that's the other project I'm on at the moment.
Hi everyone, I'm Levita. Actually, I'm from China and a student from Cliona O'Farrelly's lab. And I'm working on a side project apart from COVID, is looking at actually how natural variations in the human immune systems. So we're all different, but we're all the same as well. So I'm looking at particularly at how ABO blood groups. And as we know, certain people are blood type A, blood type O, and blood type AB or blood type B, and how that would influence susceptibility to viral infection, and potentially how that would also contribute to our understanding of why there are differences and how the immune systems are determined by these variations.
Hi, my name is Andrea. I am a research assistant in Cliona's lab. I just joined this year. I was your student last year. And during my time as an undergraduate student, I was looking into sex differences in antiviral immunity, which is what I'm going to try to do as part of this project that we're just starting on long COVID. Because as you probably know, viral infections affect males and females differently, and this is because even though we have the same cellular machinery, there are differences in how we respond to viral infections. So yeah, that would be it for me.
So this is really, really cool. Again, as Andrea said, you all know that or you probably have heard that men and women respond to infection differently. More men died during COVID than women. And we are finding in our resistance study, we're convinced that resistance is more women are resistant than men for some reason. Some of you may have heard that I studied hepatitis C for a long time and looked at the anti-D, the women who got contaminated anti-D, and was particularly interested in the women who got anti-D, contaminated anti-D, but did not get infected. And that's what started me into the realization. I certainly am alone in the first part to say that sex is a difference, well, is important. But interestingly, more women also get long COVID. So it's back to what I was saying about this enhanced better immune system that some women have that protect them against infection. That enhanced or better immune system might actually also act against them. So we don't know if it's the same thing. That's partly where it may be that the genes that we find that are responsible for resistance will be very different to the mechanism of long COVID. But it's just the sex differences is a really big, important research question.
What percentage was the deaths in males and females during COVID?
I don't have the example. It's not massive.
Right.
but it's very definite and very reproducible everywhere. Yeah. And more of the people who have to go into hospital, or go into, intensive care. That's higher. Do you have the actual figures?
I don't have figures, no.
Well, the young people would be able to remember the numbers.
Sorry, is that worldwide? Or?
Yes, that's everywhere. Yes. So we have a very interesting, to go back to collaborations and give you again an idea of how research is done. We've got a fantastic collaboration going with MIT. You might have heard about that, a very famous research institute in Boston. And there's a man there, David Page, who's really interested in sex difference. What he's interested in actually is sex differences in heart disease. Because again, heart disease is very different in men and women. And so since then, so we have this really great collaboration and an international conference actually. And there will be a public session. We're running an international conference on research conference on sex differences in immune health and disease next June, and it will be in Trinity, and there will be a public discussion session beforehand. So I bet you some of you would be interested in that.
You said earlier that there was no great evidence that supplements enhance the immune system.
Yeah.
What about probiotics?
Oh, there's a great question. And when I say no great evidence, there's loads of evidence, loads of papers, but it's to be convincing that on who benefits. That's where the real problem is. And so that's why it's very difficult to give advice to a whole audience where people are different, because as an individual, like this story is just magical, and I completely believe it. But that doesn't help a clinician. I'm only a scientist and I love hearing anecdotal stories. A clinician has to deal with all the pros. But anyway, to come back to the probiotics. So I got the students starting immunology yesterday and was telling them about the fact that the vast majority of microbes on the planet are totally harmless. We're surrounded by microbes, all sorts of descriptions everywhere. And we're covered in them. We carry about 1 kilo in our guts, in our genital urinary, in our lungs, on the skin, everywhere. All these bugs, not only are they harmless, they're essential for our health. They're actually helping to monitor the immune system so that it stays nice and quiet in one way, but and keep away the bad bugs. So the big puzzle is we actually can name the pathogens. All viruses as well. We're carrying a whole virome as what we go. So we talk about microbiome, or all the bugs. So we talk about gut microbiome, lung microbiome, skin, and viromes at the same places. So as I say, not only are they harmless, but they're actually really important for our health. So this is where it comes back to diet again. We need to be looking after. We're not only looking after ourselves, we're looking after our microbiomes. And without a shadow of a doubt, our diet's what we eat and what we do, does affect the microbiome. There's masses of research coming out on this. World-class research being done in Ireland, down in Cork, APC, Fergus Shani, you may have seen him. They've been working on this for decades. Fabulous research coming out, but nothing convincing, nothing concrete. We cannot actually yet define a healthy microbiome, so we cannot say for definite what would you eat that would help your microbiome. Is it the same as what I should take? But a generalization is back again: low fat, low sugar, or not low fat, low fat, low sugar, low sugar. All our diets in the Western world are so dominated by processed food, by salt, and by sugar, because that's what we're addicted to. That is the addiction. And the companies, now I'm going to get slightly outrageous here, the companies design stuff that is, so processed foods, the companies design, look at beans. When you take the sugar out, people say they don't like it. So it causes problems. The companies are, and so that is a research program that you could think of. Where's Mary? To invite Nora Campbell. She's in the business school down here, fabulous professor of business, teaches down there, and one of her topics is, I can't remember the exact term for it, but it's about how the unethical behaviour of companies that drive that are driven by that drive poor health. So important. But if we think about it, all things that we like. What do you like having with your glass of wine? A packet of crisps.
Chocolate.
But what do you like going to bed? Yeah, so this is what I'm saying about doing the little things, you know. Try, go for a walk. No, I'm not telling you, I'm not going to free
Sorry, here we go.
After all of that practical advice, I'd like to ask it a practical question. Do you think from an immunology point of view, the amount of pathogenic virus that you inhale or ingest has any influence on the outcome?
Yeah, so there's the amount, because this is a big problem with our study on the resistance. That's what everybody says. Did they actually get enough of the virus? So absolutely it makes a difference. And this is why for our study, we need to identify people who had slept beside someone who was positive for 3 nights. That's what we're looking for 3 nights before either were vaccinated. So, but even still, you see, this is why your question is just so great, because there's clearly huge variation between the amount of virus any individual. Just like our immune systems are different, some of us are much better at reproducing the virus than others. So, you know, if you are sleeping beside somebody who only makes a little bit, then you're not going to get it. So this is a big criticism of our study. And we cannot prove. But when you do an animal study, you see, this comes back again to what you're able to do with animals. When you do an animal study, you give them a massive amount, where you know what they talk the LD50, lethal dose of 50, where 50% of the animals will die. So that's, you're giving them way over what's needed. What's actually happening, and unfortunately it's happening, or depending on how you think of it, it's actually happening here. We're all, or at least because it's quite a big group, there's at least 2 of us, hopefully no SARS-CoV-2, but anyway, we're secreting some sort of virus. But for most of us, hopefully what's happening, when you breathe it in, that immune system that I'm saying is right there in your lungs is doing something about it. So that's if Fede was she's too humble to say, she's magic fingers. They're all geniuses. They're unbelievable. And then the magic fingers are brains as well. And she's magic fingers, and she's able to grow the epithelium from a nasal swab. We're able to get the cells from the nose, the nasal, and we think that it's those epithelial cells are able to make this very specific or very good immune response in some people. And we think that good immune response is coded for by certain genes. And but we also think that you can boost that with all of the good living.
Thank you very much.
You'll finish.
Do you have any initial thoughts on Ozempic or similar pharmacological solutions to reduce obesity directly? I mean, it's obviously a shortcoming, but it seems like we're struggling.
Absolutely. Can you remember what it's called?
Ozempic is the most popular.
Ozempic is the one, yes. There's a big discussion about this. Absolutely, we have to use it. Absolutely. That's me. Please remember, I'm a scientist, and I come out with outrageous stuff. So don't be going to your doctors and saying, she said. I'm married to a clinician, or a surgeon. If you heard of it. Anyway, obesity is causing such problems. It's increasing, it's shortening. Many of our children's generation are going to live shorter than us because of obesity. It's the first time in the human, so it's amazing what we've achieved. In the last 150 years, in terms, I gave you the statistic about the nutrition, that more are dying of excess than under nutrition. Something like 70% of the 1-year-old babies. I meant to check the statistic. I think it's higher than 70, but I didn't want to exaggerate. Of 1-year-old babies on the planet are immunized. And something like some extraordinary percentage of children under the age of 7 are going to school on the planet. So that means they'd be reading and writing at the end. So we are achieving hugely. the human lifespan has increased from, the average lifespan has increased from 50, which it was in the 1920s, 1930s when we had lots of TB here in Ireland and malnutrition and all the rest. Mainly, an awful lot of huge reason is because babies don't die anymore. The rate of baby, there are some people here old enough to remember when babies died. Lots of babies died. If humans have forgotten that, we really want to forget the bad news. And we should remember, so that we can remember and realise what we've achieved. Women don't die in childbirth anymore. It's in a massive, it's on every single newspaper, every single television, if a woman dies in Ireland in childbirth. It's just astonishing what has been achieved. But now, this 2020, this decade and next decade, that increase in lifespan is going to go down, unless we do something like that. So I can't see all of us, all of us being able to exercise more, eat less, and get off the screens.
We have a couple more questions. Sorry, I know people want to get in.
Yeah,
Here you go.
A bit embarrassing.
well, I'm actually one of those people on Ozempic. I was morbidly obese since I was 10-year-old. I spent my whole life dieting and putting weight back on, losing it, going up every time I regained it was by another half stone. So I just started out at about 15 years of age at 15 stone, and my highest weight was 29 stone. I've lost 9 stone on that medication. 9 stone. I keep saying to people, it's not about weight. It really isn't. It's about health.
Exactly.
And my problem always was that no matter how big I was when I was younger, I was one of those people who never got sick.
Yeah.
Never had a chest infection, had all my children through a natural birth, going against all the rules and regulations, because every doctor you ever looked at said, "Don't you never have this child, already you're too fat." And I went because my mother was the same and my grandmother was the same, so therefore it was in my genes. My problem now is, I've lost all this weight, I feel so much better, I've thrown away a rollator and a walking stick, but now my knees are starting to go, and I'm beginning to wonder now, is it because I'm not eating enough of the foods I need? Like I drink less milk, I eat less cheese, I eat less eggs, because my diet has totally changed. So and now I'm going to have to start really looking at and say, is it something like that that's causing? Because for me, I know it's in my genes as well, but you also have to have some form of self-help.
Of course.
But the problem with the drug now at the minute, they're curtailing it. They're telling the physicians now not to actually put out any more prescriptions for the next couple of months because of there's so little of the drug available at the moment. But I really do think that if you can catch people in their 20s and 30s before they become diabetics, before they get the arthritis, before they've really embedded themselves, to me that would be the real miracle.
I think that's good. Patrick's question really. But exactly, to add on to what you're saying, the long-term effects we don't know because they've been around only 5 years or something. So we don't know the long-term effects on rates of cancer, other diseases, like other parts of the metabolism. Absolutely. But in the meantime, it's a little bit like the anti-TNF. It's a magic thing.
It's magic for me.
Yes.
It doesn't work the same for everyone.
Exactly, but for people who don't, exactly, I would. Thank you so much. Thanks, Patrick.
Maybe one more question, if anybody, and then I'm sure Cliona will be around, well, I'm saying to be around 10 minutes or 15 minutes or so to chat informally, if you like.
Vaccination got us out of COVID, and I was delighted with that. And could we be over-vaccinated? I personally now, I'd go for the COVID if there's a new one out. I'm now looking at a flu vaccination. I'm going to travel in December, so there's vaccinations involved there. What do you feel about that? I mean, I would take anything, but I'm just, can we be over-vaccinated?
Again, another very useful question, so thank you, because this is something that really concerns people. But as an immunologist, the way our immune systems, I've been giving an idea of how extensive the immune system is. Our immune systems are capable of responding to literally millions of different structures. Okay, so we can make antibodies, literally millions, actually billions and trillions, but let's go to the small number, millions. So when you get a natural infection with something like, with a virus, there are thousands of structures on that virus that your immune system responds to. That's when a natural infection. So whenever you get a cold or anything, it's a minor infection or a senior one, or a serious one, your immune system is actually responding to thousands of things at the same time. So taking spike and flu, it's going to be no problem to the immune system.
Give me a word. I'm sure that was fantastic, and thank you very much, Cliona. You know, there's so much in it. I think we have to take time to absorb. But I just want to say thank you for coming. Hopefully you'll come to our next week, Roseanne. It'll be a good follow-on because it's about healthy ageing, and much of the topics will be time for more discussion on some of the topics or themes that Cliona brought up. But thanks very much, and if you want to just stay around for a little while and have a chat, and do come back again. Thank you.
Thank you.